Welcome back. Today we're opening the brain of the BEAR actuator, the control table. Think of the control table as a structured map of registers. By reading from these registers, you monitor the device. By writing to them, you control it. The table is strictly divided into two groups: configuration registers and status registers. Understanding the difference is key to stable development. First, let's look at the configuration registers. These define the personality and limits of your actuator. The most important thing to remember: values here are only permanent if you send a save config command. Otherwise, they reset to the last saved state upon power off. Key registers include ID and baud rate. Every BEAR in a chain needs a unique ID. Our default baud rate is lightning fast 8 megabits per second. PID gains. These tune your current, velocity, position, and direct force loops. Limits. From limit Imax for torque and limit velocity max for speed, to limit accelerate max for smooth trajectory generation, and limit position to define your workspace. These are your hardware's guardrails, ensuring your robot moves safely within its physical design limits. Safety thresholds. You can set voltage and temperature limits here. For example, when temperature limit low is hit, the motor starts throttling power to protect itself. Next, we have the status registers. Unlike config registers, these are volatile. They reset at power on. They are used for real-time interaction. Torque enable. As we discussed in the safety video, this is the master switch. It controls whether the motor is active, disabled, or in an error state. Goal registers. These are your commands. Depending on your mode, you'll write to goal IQ, goal velocity, or goal position to tell the BEAR what to do. Present registers. These are read-only. They provide high-speed feedback on the actual current, velocity, position, and input voltage. Thermal monitoring. You can track 3 different temperatures: the winding, the power stage, and the IC, ensuring total thermal transparency. So, the workflow is simple. 1. Set your limits and PID gains in the config section and save them once. 2. During operation, write to the goal registers to move the robot. 3. Continuously read from the present registers to monitor performance and safety. Theory is good, but let's see it in action. To make debugging and tuning easier, we've developed the BEAR Data Control GUI, a graphic interface developed based on LabBEAR that brings the entire control table to your fingertips in live motion. First, visit our GitHub repository and scroll down to the LabBEAR repository. Click on Releases on the right-hand side, where you'll find the latest utility tool. Simply download, extract the zip file, and install it. This interface is organized to match the logic we just discussed. Real-time monitoring. On the right, you can see the status registers plotted in real time. Everything from IQ current and velocity to winding temperatures and bus voltage is visible at a glance. The command center. Here, you can read or write configuration registers. Want to change the limit? Just type it in and hit Write Config. Safety and ID. You can switch between multiple BEARs in a chain by simply changing the ID, and use the dedicated Enable, Disable, and E-stop buttons to manage the torque, enable status. For those looking to push their robot's performance, the GUI offers dedicated PID settings. You can fine-tune your current, velocity, and position loops on the fly. To analyze the frequency response and dynamic characteristics of your joint, use the Chirp panel. This versatile signal generator allows you to send various reference goals, including chirps, sinusoidal waves, and square waves, to evaluate exactly how your BEAR responds under different dynamic conditions. It's an essential tool for professional-grade joint tuning. By mastering these registers through the GUI, you gain total transparency into your robot hardware, finding the perfect balance between speed, power, and safety. Speaking of balance, the PID gains at the bottom of the screen are the key to that smooth, bio-inspired motion we all strive for. In our next video, we'll perform a deep dive into PID tuning to help you reach peak performance. Head over to store.westwoodrobotics.io to download the full SDK manual. Let's bring your robot to life.